Hello everyone, Assalamu alaikum. Today we learn an interesting topic that's Cipher algorithm in cryptography. Cryptography. Cryptography is a science and practice of sourcing communication and information by covering it into a code to prevent unauthorized access. The primary goal of cryptography is to ensure that sensitive information remaining confidential and resource during transmission or storage. Now we see the Cipher algorithm historical background. The Cipher deserves its name from the Roman military and political leader Julius Caesar, who is believed to have employed their encrypting technique during the campaigns for resource communication. The historical content of the Cipher using can be tracked back in the ancient Rome around 58 BCE or 50 BCE. When Julius Caesar invent this method, then he will encrypt her text within three letters. Suppose A is a letter and he will decrypt starting from D. So in this picture we see here is A, it will be encrypted from D, and B encrypted from D, and C it is starting from F, so that at the end of XYZ will be found with ABC. So now we show how cryptography encrypted process Cipher will be working. The working principle of Cipher is based on concept of a subsolution cipher, a type of encrypting where each unit of plain text using a single text is replaced with another unit, typically another letter or symbol. In the case of Cipher, this substitution is converted through a straightforward shift operating on the alphabet. The substitution cipher employed by the Cipher involves shifting each letter of the plain text by a fixed number of positions down the alphabet. The fixed number is known as the key or shift value. For example, with a shift value of 3, a word will be replaced by D, B by E, C by F, and so on. The shift is calculated, meaning that after researching the end of alphabet, it wraps around the beginning. An example, let's encrypt the message hello using a Cipher with the self value of 3. Original message hello. Applying the shift, H shift by 3 position become K, E shift by 3 position become H, L shift by 3 position become O, again L shift by 3 position become O, O shift by 3 position become R. The encrypted message is KHOOR. So the encrypted from the message hello is a Cipher and a shift value of 3 is core. After that we see the encrypting process. In input we see here is a two value. First of all, plain text which is input method, that is called P, and shifting value, that's encrypting key, it's called K. After initialization, create a empty cipher text starting with C. Encryption step. For each character Pi in the plain text, apply the shift operation Ci equal to P plus K. Apply the resolution character Ci to cipher text C. Output C is cipher text encrypted message. Now we see a simple example. Our plain text is apple and shifting value 5. First of all, we write here our plain text P equal to A P P L E. Now we know the alphabet value in English. Suppose here A equal to 1, P equal to 3, so that we can say English alphabet are 26, so everyone has a value. Now we using index value in P1. Here A is equal to 1, P is equal to 16, P is equal to 16, L is equal to 12, E is equal to 5. Now we using our encrypted key, and encrypted key value here is a 5. Now we using the shifting operation Ci equal to P plus K, so that our p value, pi is a index value, p1 plus 5 equal to c 6, 16 plus 5 equal to 21, 16 plus 5 equal to 21, 12 plus 5 equal to 17, and 5 plus 5 equal to 10. Now we got a cipher text index value. Now we find out the index value with letter, and they found it c equal to fuqz. So now we called Apple word encrypting by Fuku's. Now we see the decrypted process. First of all, we see a cipher text, which encrypted message and shift value, that's k. Initialization part with a plain text. Description steps, for each character c1 is the cipher text applying the inverse shift operation ci minus k. Appending to the resolution character pi to the plain text p. So plain text is a output. So now we selected a cipher text focus and shift value is 5. Now we write our cipher text, and we compare our cipher text value with index value, and our index value is 6, 21, 21, 17, 10. Now we editing our shifting value 5, 5, 5. And we calculate the pi operating by encrypted state ci plus k. It's called it will be b minus, so that 6 minus 5 equal to 1, 21 minus 5 16, 21 minus 5 16, 17 minus 5 equal to 12, 10 minus 1 equal to 5. Now we got the plain text index, so we can convert our text into letter, so that p is equal to a p p l a. Now we say focus decrypt by Apple. Now we have a code implementation. Here is a cipher text. Here is a scissor cipher algorithm implement in Java. So here is, we see there is a main class, and main class under we create a method that is encrypted method, and we here declare that string build result equal to new string build, and for here is a condition I equal to 0 and I greater than message length so it will be greater than. For character and uppercase and lowercase also be verified here, so we have also be a mathematical method, given character with plus encrypted key, and that will be minus by 65, and this module by the base of English alphabet 26 plus 65. As a result, we see here is a public statement string decrypt section, and decrypt section we have a new string builder, and there is also be a mathematical term, that's key is equal to 65 plus 26 divided by 26 plus 65. For this it will be code implement for scissor cipher. Now we see the output of this code. So here is our code, and we can starting our code run out. So this is a IntelliJ platform, and our code are typing by here. So now we can run our code, and it will be building. After building that, we can also be a output skin, and here is a message, enter the message to encrypt. Now we enter our encrypted message a double p l a here is a mistake, so a double p l a Apple, and we using the upper layer alphabet, and after that we can enter, then it will be value for 5. Then it's automatically encrypt by Fuku's, and after Fuku's word will be decrypt and Apple word. So that's all for today. Next we learn another interesting part.